Now we need to go through some internal resistance and output power considerations. When the Mini N machine is ran at the motor's operational speed of 2,900 RPM, the resulting output voltage is 0.468 volts. This is the open circuit voltage, which represents the rated output voltage of the generator at that particular speed. In order to test the machine, the generator output terminals must be connected to an electrical load in order to draw off power so it can be measured. To do this, a load bank was constructed so that varying levels of load could be applied to the machine. As I explained earlier, the load bank is able to go down to 5 milliohms resistance using 20 0.1 ohm resistors in parallel. However, it was realized during the testing phase that the minimum resistance of this load bank is in fact significantly higher than 5 milliohms. This is due to additional resistances within the circuit which are normally considered negligible, such as closed switches and terminal contacts, which come into play when the overall resistance of a circuit is very low. Each of the 20 resistors, for example, has a 30 amp switch so that the resistor can be turned on or off, 30 amp rated I mean. Switches, when closed, have a finite contact resistance, which adds to the overall resistance of the circuit. Now, if we consider the equivalent circuit of the generator produces voltage V and a current I, which runs through the disc, across the brushes, through cables, through two large parallel wired switches, then into the load bank, and back through another set of brushes, onto the rotor and back to the disc. Now the rotor and disc have an electrical resistance. Let's call that RM1. The rotor brushes have an electrical resistance. Let's call that RM2. And the disc brushes have an electrical resistance. Let's call that RM3. The rest of the circuit, which is the loading side, has a value of resistance, and we'll call that RL. We can simplify this circuit by combining RM1, M2 and M3 as a single resistance and call it RM, which is the total internal resistance. So we have a circuit containing two resistors in series representing the internal and external or load resistance. To get the maximum power output into a load resistor requires that RL equals RM. If we made the load resistance RL the same as the internal resistance of the machine RM, that would produce the most amount of useful power into the load. However, this is not the actual maximum power output of the machine. The maximum power output occurs when the resistance of the load is at the absolute minimum, i.e. with a zero load resistance, RL equals 0, such that only the internal resistance is providing a load. In this scenario, all of the power is being dissipated within the internal resistance of the machine. Although the power is internal, this still counts as generated power and is achieved by short-circuiting the output terminals. This is how De Palma and Valone tested their machines to extract the maximum current output and hence power by putting a short circuit across the output terminals of the generator. So using the Mini N machine with the load bank connected with all the switches closed, the machine produced an output current of 17 amps. I introduced some additional 0.01 ohm resistors into the load bank. This increased the output current to 29 amps. I then removed the load bank and just used three 0.01 ohm resistors in parallel as the load. This produced an output current of 39 amps. I then removed the resistors altogether, leaving just the two load switches in the circuit. This produced an output current of 65 amps, which climbed to 105 amps after the brushes had warmed up. Finally, I removed the switches altogether and placed a dead short across the output terminals, which resulted in an output current of 170 amps, which equates to a maximum power output of 79.56 watts. Note that in all these cases, when a current is drawn, the output voltage on the meter is seen to drop lower than the open circuit voltage of 0.468 volts. This is due to the fact that the voltage being measured is across the external load resistance and the rest of the voltage is being dropped across the generator's internal resistance. To calculate the total output power, it can be assumed that the overall voltage is in fact still the same as the open circuit voltage. So we multiply the open circuit voltage by the output current to get the total output power. A slight adjustment needs to be made with this machine, however, in that when the load is added, the induction motor speed decreases very slightly, typically about 0.2%, and hence the voltage output will decrease by this exact same amount. So in order to calculate the output voltage when the machine is loaded, we take the open circuit voltage and multiply that by the ratio of the closed circuit speed to the open circuit speed. This is then multiplied by the measured current output to work out the total power output. Now, when the machine was ran over a period of a few minutes, the output current, and hence the output power, gradually increased by about 50%. This is due to the brushes warming up over time, and it could also be due to the contact resistance of the closed circuit breaker switches and the terminal contact resistances decreasing as they warm up due to the heating effect of the electric current. As all these components warm up, the electrical resistance across the interfaces reduces, producing more output current. The brushes also present less friction as they warm up, which results in a simultaneous gradual reduction of the input power. So now to the testing. I conducted two tests. The first test consisted of using just the two circuit breaker switches wired as the load and turning them on and off at 10-second intervals for 10 cycles. While doing so, a video was made which recorded all of the instruments. Okay, so this is a video of the test run of the homopolar generator N machine, and what it's going to consist of is running the machine up to speed, then switching the load on for 10 seconds, then switching it off for 10 seconds, on for 10 seconds, off for 10 seconds, 10 full cycles with all of the instruments recorded. I've got an audio signal in order to time the 10-second intervals. I think the output current should be in the region of 60 amps with the way that I've got the load configured. Alright, so let's start it up. So the input power is 707 watts, and it's coming down slowly as it normally does as the brushes warm up. Still coming down. Okay, I'm going to start the timing now. The results were then plotted on a graph. Now note that the efficiency of the motor at full load is stated at 77.4%. So this means that the actual power transmitted to the generator via the shaft is 77.4% of the value measured on the power meter. Therefore, this was adjusted before plotting the graph. Looking at the graph, the top blue line is the generator speed, which you can see decreases slightly each time the load is switched on, and then increases again when it's switched off. This means that there is some back torque felt on the shaft as a result of the electrical power generation. This is because of the way an induction motor works. When the load is increased, the speed slows down slightly, which results in a higher torque being produced and more power delivered. The motor will automatically move to a new speed at a point where there is enough torque to satisfy the new load. But is the amount of extra input power extracted from the motor more or less than the electrical power being generated? That's the question. Now, looking at the red line, which is the input power, there is a downward trend until about 150 seconds. This is due to the brushes warming up and presenting less mechanical resistance over time. Looking at the green line, the electrical power generated, we see an upward trend in the output power. Again, this is due to the brushes and other interfaces warming up and exhibiting less electrical resistance. Now, what we are interested in is the change in output power relative to the change in input power. The change in the red line relative to the change in the green line. And we can see the output power being switched on and off at 10-second intervals. If I move these transitions up to compare them with the input power, it is clear on this graph that the change in output power is slightly more than the change in input power. I would estimate maybe 20% or so. De Palma and Trombley suggest the difference should be around 500%. Now, this difference of 20% might be down to instrumentation or measurement errors. I don't think it's large enough to draw a conclusion of any kind, really. But nevertheless, this does seem to show that more electrical power is being produced than the extra power required to create it. So I did a second test. Now, from the graphs, it is clear that after the generator has run for a few minutes, the output power relative to the input power increases significantly, with larger current being drawn off. Now, I thought that perhaps as the current climbs, the over-unity effect becomes greater at a higher current. So I decided to run the generator loaded for a period of a good few minutes with the circuit breaker switches closed until a high-ish steady current was reached. So I waited until the current stopped climbing and it seemed pretty fixed, and the input power seemed pretty fixed as well. I waited for those levels to settle. Then I opened the circuit breakers and instantly removed the load and measured the difference in the power levels immediately before and immediately after the switchover. The power from the generator is running through the two switches. That's all the load is. So I'm going to run it for maybe a few minutes to get this current to stabilize. I want to get it as stable as possible so that the output current is stable and the input power is stable. And then I'm going to open these two switches and record the parameters then. Okay, so let's go. Right. Right, that seems to be quite stable now. 104 watts, 104 amps, 105. And here is the calculation. So with the load immediately before the switch opened, the input power equals the measured electrical power in times the efficiency rating of the motor, which is 711 watts times 0.774, which comes out at 550.314 watts. The output power is the open circuit voltage times the ratio of the loaded and unloaded speed times the current. So that was 0.464 volts times 2903 divided by 2912 times 105 amps, which is 48.69 watts output. Without the load, in other words, immediately after the switch was opened, the input power is equal to the measured electrical power in times the efficiency rating of the motor, which was 664 watts times 0.774, 513.936 watts. So we can compare the input power and the output power. The difference in the input power is 550.314 watts minus 513.936. So that's a difference in input power of 36.378 watts. So the change in input power was 36.378 watts and the output power was 48.569 watts. That is an additional 12.191 watts, which represents an increase of 33.5%. And here is the resulting graph. Now, the instruments that I used, the voltmeter was 0.5% accuracy, the ammeter 1%. The power meter I don't have a value for, but I suspect it's similar, 1%, something like that. So I don't know whether those errors can cancel out that 33.5%, but it's certainly very interesting. Assuming the figures are correct, it means that the system was outputting an extra 12 watts than expected from somewhere. So have I been pulling 12 watts of power out of the quantum vacuum? I don't know. I'm not sure. If anyone has any ideas of how I can further investigate this by suggesting modification to the device or other experiments, please email me at richard@richplanet.net. The results appear to show a small amount of additional power output, possibly 33.5%. But is this large enough to convince me? I'm not sure. And I have considered how to increase the output power of the generator in order to conduct further testing. The two modifications I could make, firstly, I could add another set of rotor brushes. This would halve the resistance of the rotor brushes and therefore probably increase the current by quite a lot and therefore the power. I could also introduce a variable speed motor capable of much higher speeds. This does have safety implications. So if I ran a motor at twice the speed of the current one, the output current would double from 105 amps to 210 amps, which means the output power would increase by a factor of 4. But hopefully it would only double the increase in input power. Maybe, not sure. So this then may show a much larger than 33% difference between the incremental input and output power. If the input power doubled and the output power quadrupled, would the figure be 206% as I've calculated? I don't know. So if it could get up to 200%, that would be a lot more convincing than the 133% that it currently is. So if anyone has a 6,000 RPM, 2.5 Newton meter, 2 kilowatt motor hanging around that they want to loan me, please get in touch. Variable speed would be preferable. And I don't want to be near it when it's started because it is quite scary. So unfortunately, I'm going to have to leave the study hanging there until a future episode. No firm conclusion, but certainly these tests have not debunked it. They've just made it far more interesting. Now, with regards Bruce De Palma's N machines, there are plenty of claims made by De Palma himself, but such claims made by the inventor are not considered to be of any value in terms of independent verification. As far as I am aware, there is only one independent test that has been documented which reports on the performance of one of Bruce De Palma's N machines. This was a test carried out by Robert Kinchlow, Professor of Electrical Engineering at Stanford University in 1986, and the test was on De Palma's Sunburst N machine. The entire report can be found here. It is quite technical and I had to study it carefully to understand it. I will go over the most important findings. The Sunburst machine itself has a different arrangement to the one I built. The magnetic field is produced by an electric coil, not a permanent magnet, which goes around the circumference of the spinning metal disc. Although the disc is more of a cylinder shape than a disc and is made of soft iron, not copper. As with all N machines, the magnet and disc rotate together. Now here is the important bit summarized in this table from Kinchlow's report. Just go through it. The measurements in all three columns were taken when the machine was running at 6,500 RPM, and I'll just go through them. The first column shows the motor's power input when the electromagnet and the output load are both turned off, which is 4,782 watts. So this is the power required to overcome the friction of the brushes, bearings, and any electrical losses in the motor. 4,782 watts. That's a lot and shows that the friction on the brushes was large. The middle column is showing the motor's power input and output when just the electromagnet is turned on. Now note, this is not the power going into the electromagnet. It is the increase in power required to drive the motor when the electromagnet is turned on. So turning on the electromagnet presented an additional input load of 444 watts, taking the power input up to 5226 watts. The third column shows the power input to the motor with the generator load connected. This caused an increase in input power of 802 watts, taking the motor's total power input to 6,028 watts. Now, looking at the generated voltage of 1.28 volts and the generated current, 4776 amps, equates to an output power of 6,113 watts. So 802 watts of additional power in created 6,113 watts out. That is a 662% more out than in. And Kinchlow adds, the total system efficiency is still less than 100% because the generator magnet power, approximately 2,300 watts, and the motor field power of about 144 watts, which must be added to the motor armature power to obtain the total system input power. So this is how these results would look on the power diagram I showed earlier. Now you might ask, how is De Palma getting such high current out of his machine? This is down to the brushes he was using, which had a surface contact area of 30 square inches, which is why the device takes over 4 kilowatts to keep it moving. Now, as I mentioned earlier, if I was to increase my motor speed, I might see a higher power ratio than 133%. Is this why De Palma's machine achieved over 600%? Because of the much higher power that his device put out. We must bear in mind that these results do not come from De Palma. These results were derived by a professor of electrical engineering at Stanford University, not by Bilbo Baggins from Bamber Bridge. And again, we see the major problem preventing a truly over-unity device, which is the brush friction. If the brush friction was reduced, the motor's power input of 4782 watts would be vastly reduced. If we take heed of what Kinchlow said and add in the other factors, okay, we get 6028 motor power input plus 2,300 watts for the magnets and 144 watts for the motor field current. That's 8,472 watts in total. The output power from the homopolar generator was 6,113 watts. Now, taking the difference, we get 2,359 watts. That means if the brush friction could be lowered so that the motor's input power was reduced from 6,028 watts down to 3,699 watts, then the machine would be fully over unity. And I think it's perfectly plausible that if 30 square inches of brush contact were replaced with liquid metal contacts, that this could be achieved. And this is exactly what De Palma and Trombley are alleged to have done in subsequent machines. However, I am not aware of any independent examinations of his liquid metal brush N machines, which is very unfortunate. In order to improve such devices, if liquid metal brushes are used, which have a large surface contact area with the rotor and disc, providing very low friction and very low electrical resistance, such a device could be world-changing. Now, Kinchlow knew that publishing such earth-shattering results could represent a huge new discovery in physics and was cautious when writing up his conclusions. Let's have a look at what he wrote. We are therefore faced with the apparent result that the output power obtained when the generator magnet is energized greatly exceeds the increase in drive power over that needed to supply losses with the magnet not energized. This is certainly anomalous in terms of conventional theory. Possible explanations. 1. There could be a large error in the measurements resulting from some factor such as noise, which caused the digital meters to read incorrectly or grossly inaccurate current shunt resistances. If the measured results had shown that the computed generated output power exceeded the input drive power by only a few percent, this explanation would be reasonable and would suggest that more careful calibration and measurements might show that the results described above were due to measurement error. With the data showing such a large ratio of generated power to input power increase, however, in my opinion, this explanation of the results seems unlikely. A later test showed that the digital meters are insensitive to a large AC ripple superimposed on the measured DC, but within their rated accuracy of 0.1% give a true average value. So the meters are okay. Number 2, there could be a large difference between the measured voltage at the metering brushes and the actual generated voltage in the output brush circuit due to armature reaction, differences in the external metering and output circuitry geometry, or other unexplained causes. As discussed above, the various data do not seem to support this possibility. Number 3, De Palma may have been right in that there is indeed a situation whereby energy is being obtained from a previously unknown and unexplained source. This is a professor of electrical engineering saying this, who did his own tests on the machine. This is a conclusion that most scientists and engineers would reject out of hand as being a violation of accepted laws of physics and, if true, has incredible implications. Number 4, perhaps other possibilities will occur to the reader. He goes on, the data obtained so far seems to have shown that while De Palma's numbers were high, this is De Palma's own numbers before the test, his basic premise has not been disproved. While the sunburst generator does not produce useful output power because of the internal losses inherent in the design, a number of techniques could be used to reduce the friction losses, increase the total generated voltage, and the fraction of generated power delivered to an external load, which is what I just said. De Palma's claim of free energy generation could perhaps then be examined. I should mention, however, that the obvious application of using the output of a free energy generator to provide its own motive power and thus truly produce a source of free energy has occurred to a number of people, and several such machines have been built. At least one of these, known to me, using what seemed to be good design techniques, was unsuccessful. So he knows of another machine that didn't work. What's that got to do with this one? So it seems to me that Kinchlow was struggling to explain away the results that he himself derived from his own tests, and my results have not disproved De Palma's claims either, and hopefully there's going to be some more tests to come. Now, De Palma went on to build new machines with mercury brushes and claimed his device did in fact produce more total power out than was put in. Now, looking at the results in Kinchlow's test report, if they are correct, and there's no reason why they're not, if De Palma did go on to make machines with metal brushes, then I would say it's likely that he did produce something which was over unity. But as far as I am aware, there are no independent tests like the one Kinchlow did that are available that were carried out on the later liquid metal brush machines. Now, it's no surprise that after this report became public, academic skeptics had their say. Here's one example. This article is from Duncan G. Cumming, who has a Cambridge PhD and a background in electronic engineering. In 1990, he wrote, I examined Kinchlow's test data to see what kinds of errors may have been introduced. The input power had not been measured in the usual way with a dynamometer, but instead the electrical input to drive the motor had been measured. This was a much less accurate technique. Also, the drive motor was coupled to the generator by means of a drive belt, introducing further unknown errors. Even more serious was the considerable brush friction in the generator itself. Why is that serious? In fact, the various losses amounted to several times the generator power under most conditions. To get around this problem, two measurements had been made, one with and one without a load. The increase in input power was then compared with the increase in output power. However, this created ill-conditioned data and was an inaccurate technique. Ill-conditioned data. Could any conclusions be drawn from these data in spite of the possible inaccuracies? I felt that Kinslow's experiment was inconclusive regarding the incremental power gain. I spoke with Kinslow on the telephone to see if he could shed any further light on his remarkable results. He acknowledged that his experiments were done on a ranch in Nevada in a remote location, with limited time and using apparatus provided by Palma. Furthermore, he had not personally calibrated a shunt, one of the key components in the experimental setup. He admitted the possibility that the unpublished measurements were in error, and he asked the inventor about the possibility of conducting further tests at Kinslow's home. He had received no reply to his request, and meanwhile De Palma had moved on to the construction of yet a larger, more sophisticated N machine. Well, why wouldn't he? I am told that the new machine, built at considerable expense, is superbly crafted and contains some 200 pounds of rare earth magnets. So why not ask to go and test it? What can be learned from this? I think the most important lesson is that there are many scientists with sufficient interest to investigate new energy ideas. Scientific laws are not legislated, so attempts to pass special bills in Congress, as Newman is attempting, are futile. What is needed to interest a scientist is a series of reproducible measurements. Measurements of a machine running at a high crest factor are of no interest if the crest factor is not even measured, particularly in view of the easy availability of instruments for the purpose. Also, a single data point is of limited interest. A credible scientific experiment should produce a series of measurements over a range of conditions, such as angular velocity, excitation, voltage, etc. If such measurements are carefully performed and indicate a new source of energy, I guarantee that the scientific community will be interested. As in the case of the N machine, somebody will be inspired to repeat the experiment and refine the measurements. It is true that if the results eventually prove to be negative, they will probably not be published in the mainstream scientific literature. This simply reflects the adage that extraordinary claims require extraordinary proof. If the proof is not forthcoming, then there is little point in publishing the claim. But the interest is definitely there, and I am confident that if a new energy source were to be discovered today, it would be recognized and exploited with remarkable speed. I get the feeling Duncan Cumming doesn't want to discover a new source of energy. Rather than chase the man who did the tests, why not take some ownership of the controversy and go and get involved in the testing yourself? Perhaps on the new liquid metal brush N machine that De Palma did develop after this one. Anyway, that's just about all for now. Finally, just to inform you that I have been trying to get in touch with Adam Trombley, who built a closed-path homopolar generator which was alleged to produce more power out than in, and I have submitted a number of emails to him via his website. Now, I did speak to him many years ago, but so far he hasn't got back in touch. I'm not sure why. Perhaps the gagging order that it was alleged was imposed on him over his patents by US authorities is preventing him from contacting me. I don't know. However, I would very much like to speak to him. He would be the man to talk to get some further discussion on this subject and perhaps give advice. So join me again next time for more investigation into energy. There may be an update on my mini N machine, and we will perhaps get Andrew Johnson, who's been very badly missed on the show, to put in an appearance. And until then, believe none of what you hear and question everything you see. I'm Richard D. Hall. Good night.